Okay, this is the opening video of our expressions and equations unit. Expressions and equations are truly the backbone of algebra. Expressions are mathematical sentences that contain numbers, symbols, and operators. They represent a value or quantity or number. Here's an example of one, 5x plus 3. You can see I color-coded it. And here's another one, x squared minus x. So let's take a moment to break these down, because as with all mathematical structures, they contain parts that have names. So let's begin to be able to use those names. So in this slide, you see that the first basic separation, the first basic piece of vocabulary that we need to know about expressions is that expressions are made up of terms. All three of these terms can be a number. Terms can be a number multiplied by a variable, or a term can just have variables in it. The terms also contain an operator, which means that when we go to combine like terms and start to simplify these expressions, this sign goes with this term. This sign goes with this term. And when you have something out in front, if there's no sign at all, the default is positive. Otherwise, you could see a negative sign out here. But when there's no sign at all, it's meant to be signaling a positive number. Okay, here we are breaking down the exact same expression into even smaller parts that all have names. I'm capturing screenshots of all of these panels, and I will upload them for reference so that you can look at them at another time, like taking notes. So the first thing I want to talk about are these two terms here, constant and variable. Let's talk about variables first, because they are like the hallmark of algebra. I mean, that's the whole point, right? Algebra is sort of abstract, and things can mean different letters can mean different numbers. So that's the point of a variable. A variable is usually a letter, and it stands in for a number. It is a quantity that varies. It can change, and it will change the outcome of whatever the expression is. So on the other side of that coin is a constant. A constant is just a number. I mean, if you think about it, it makes logical sense. A variable can vary. It can be anything. A constant, this is always going to be 2. No matter what happens to the rest of this expression, this is always going to represent 2. So it's constant. Then we've got another way to express numbers that are being multiplied by variables. And the reason that we know they're being multiplied is that's another thing about algebra, is that when you have two things written right next to each other and there's no operator in between that you can clearly see, then the default operation in that case is multiplication. Well, When a number gets multiplied by a variable, that number has a special name, and it's called a coefficient. Coefficients are very important when you're dealing with standard formulas, and we talk about coefficients a lot second semester when we're talking about quadratic equations and the quadratic formula in particular. And then last but not least, we have these little numbers that are often written at the top right of a variable. These are called exponents, and exponents are just a shorthand way to represent repeated multiplication. Now we'll go into this a little bit in more detail, but for now, let's just accept that what this stands for is x times x times itself. Okay? So expressions can be translated from math language to words and back again. This is a very handy skill when solving word problems in particular. Okay, and to end this particular video, here are some examples of translating expressions from words into math language. So here we have 5 times the sum of a number and 2. So this is 5 times all of this stuff. Okay, so that's going to look like this. 5 times the sum. So you know that once it says sum, that n and the number are one thing. So the sum of a number, and sum means addition, so it's n plus 2. Let's go to the next one. The difference of 8 and a number times 3. So if you say the difference of 8 and something else, that means that 8 is going to be subtracted. Okay? Oh, nope. Mrs. Heinzman's wrong. The difference of 8 and a number times 3 means 8 gets written first, minus a number times 3. So if they say the difference of something and something else, the something goes first and the something else goes second. And last but not least, the quotient of 4 and a number, comma, plus 7. So the quotient means we're going to divide. So 4 and a number plus 7. So hopefully these examples made sense to you. So now you will have an opportunity to do some practice with a digital activity and more practice after that.